Hello everyone, welcome back to this channel. So we are continuing our data science course. As of now, we have completed the basics of Python and also NumPy library, Pandas library and Matplotlib library. Okay, so today we are going to learn Seaborn library. Okay, first let me tell you why it is used. It is mainly used for visualization. Can you tell me the name of another library which is also used for visualization purpose? We have studied Matplotlib. Okay, but there are some basic differences between Matplotlib and Seaborn library. We will learn about all those things, but as of now, just know that Seaborn has some more advanced features than Matplotlib. Okay, that doesn't mean we can ignore Matplotlib. That has also its own benefits. We will learn about all these things. Okay. Now let's see these are the categories or we can say these are the types we can plot using Seaborn library. Okay, relational plot, distribution, categorical, matrix, multiplot and regression plot. We are going to know about all these plots in detailed manner. Okay. Now first of all know that there are two categories of plots. Number one is figure level, number two is axis level. Whenever we plot something you can see this is a container. This container we can say is a figure and inside the container the graph, the plot that is an axis. So we can use figure level function or we can use axis level function also. Clear? But you can see that here there is one figure but two axes. So within a single figure you can have multiple axes. Okay. So if you want to create an individual plot, you can directly use axis level function. But if you want to create multiple plots, like you want to show the complex relationships, then you can use figure level function. We are going to learn about both of this. Okay. Now first one is relational plot. Relational plot is a figure level function. But scatter plot, line plot, these are the types of relational plot. These are axis level function. So how can I plot scatter plot and line plot? We know these plots while studying matplotlib. Here also the concept is same. To find the relationship between two variables, we can use scatter plot or we can use line plot. Fine. Now let me show you how it looks. First let me copy paste. See here. First I have imported Seaborn function. I have given a alias name, nickname, SNS. By using SNS, I am going to call the functions which are in Seaborn library. Next, I have also downloaded Matplotlib because sometimes we may use this one also. Okay. And in the Seaborn library, there is a data set. The name of the data set is tips. So first, let me show you how it looks. So I have first simply loaded the data set. Now, if I want to see the data set, then I can write tips. This is a data set which is already in C1 library. We have just loaded it. Okay. See in the data set, there are 1, 2, 3, 4, 5, 6, 7 columns. First column is total bill. Second is tip. How much people are providing tip. What is the sex? Whether smoker or not. Which day they came. Whether they did lunch or dinner. And how many people came together. So these are the data we already have in the tips dataset, which is already loaded in Seaborn and we have just downloaded the dataset. Clear? Now let's see how we can generate a scatter plot. So sns.scatter plot. Here I have to write x equal to total bill because I want to see what is the relationship between total bill and tip. Whether it is increasing, decreasing or even it is not affecting at all. Okay. For that I'm going to plot a scatter plot. So I have to write y equals to tip. And I have to provide data equals to data is a parameter where I have to provide the data set. That means I have to mention from where you are going to take the data. Okay, so it is take the values from the tips data set. It will keep total bill in the x column, tip in the y column, and it will create a scatter plot. I am so sorry. Okay, so you can see the relationship between total bill and tip. Okay, so this is an axis level function. Now let me show you how it looks if I use figure level function. What is the figure level function? The rail plot. Now within rail plot, I want to write x equals to total bill, comma, y equal to tip, data equal to tips. Here I am drawing a figure level function, this one. Okay, I have already plotted axis level function by using scatter plot, but now I am drawing a figure level function. I am using relational plot. So relational plot can be of two types. See here, it can be a scatter plot, it can be a line plot. So I have to explicitly mention what is the kind. So here I have to use one more parameter, that is kind. So kind equal to scatter. Now if I run it, clear, the same plot, but it is looking a bit different. Let me show you. Here it is more white, looking like a rectangle, but here it is not looking like a rectangle. It's not that much of white. So this one is figure axis level function. This one is figure level function. Clear? But both of them producing same output. But here I have to mention kind parameter while you are using the figure level function. Clear? Now let's see what is a line plot. Same. Let me just copy this. If I want to apply on this one, then I have to just change it to line plot. Now if I run it, see what happens. Clear. See, if you want to see the relationship using line plot, you can use line plot. In scatter plot, every point is not connected. In line plot, every point is connected. Okay. So here also you can find the relationship. Now you will be able to understand more with some, if you use some meaningful column. Like if I use line plot on is equal to size, is equal to size, y equal to total bill. Now see, I want to see whether it is increasing with size. Obviously total bill is increasing with size. Okay, so this way also you can draw line plot. But if I want to use figure level function, then same rail plot. Inside this, let me copy this one. If I copy, I have to mention kind equal to line. Then if I draw this, okay, same. It is more white because it is an axis level function. This is a figure level function. So by using rail plot, you just have to mention kind equal to scatter or kind equal to line. If I don't provide kind, then what happens? What do you think the output will be? Just because this is by default, this is a scatter plot. Okay, that's why it will be shown the scatter plot. But if you want to mention that it is a line plot, then you have to write kind equals to line. Like here also, if I just don't give kind equal to scatter, the same output will be generated because by default it is a scatter plot. Now tell me, what is the difference if I use the matplotlib function? Can you tell me? Do you remember? There we did not write x equal to total will. We wrote total will, comma, tip. And we didn't need to mention data equal to tips. Okay. But see here, automatically total will is printed. Tip is printed. But in matplotlib, we had to write plt.x level, plt.y level, plt.title. Okay, but here you don't need to explicitly mention the x level or y level. So for writing or for creating a same graph, you have to write less code in Seaborn library. Fine. But if you want to change the name, so you can just import matplotlib function, this one, and you can give plt.x level. Let me show you. If I write plt.x level and within this I write bill. Now see what happens. See, X level is changed. Okay. So if you don't provide also, then also the name will be, the by default name will be automatically printed. But if you want to change the name, that also you can do. So you understand the advantages of matplotlib function and the advantages of Seaborn function and where and how to use all these libraries. Okay. So we have completed relational plot. We have completed this one. Now let's understand distribution plot. Okay. Now distribution plots is used to visualize the distribution. You can do this using histogram using KDE plot or using a RAG plot. Let's see all of them one by one. First, histogram also we know. Histogram means you have to create bins and you can perform on single column. First, let me delete this one and let me write it 10. Just see. Bins equal to 10 means the total bill column divided into 10 parts, and we want to see that what is the distribution of the total bill. So here this is the range where the bill amount is highest. Okay. By using histogram, you can find the frequency. Fine. Now let's understand KDE plot. KDE plot is mainly used to estimate the probability density. We have not studied about probability density yet, but we will learn about probability density while studying probability. For now, just see that you can simply do a KDE plot. KDE plot on a particular column tips total bill, that means on total bill it will generate a KDE plot. Set equal to true means simply there is a set, you can see. If I just remove it, sorry, then let me show you, it will be blank. Okay. Probability density is mainly used for continuous variable. Probability is used for discrete variable. Probability density is used for continuous variable, because in continuous variable if a number can be like 0.2, 0.3, 0.235, there can be any number, and probability of generating any continuous number is almost equal to 0. That's why instead of using the probability directly, we use probability density. Now it will not be clear because these things we will study while studying probability. So as of now, you can just simply understand that we can generate KDE plot also. Fine. Next one is RAG plot. Let me show you how it looks. This is a one-dimensional representation. Okay, along a single axis. See how it looks. This one. Okay, so you can see that the maximum bill is generated in this range. Okay, so this is also known as RAG plot. Rarely used, but mainly used with other plots. Okay, so we have completed relational plot and distribution plot. Next, understand categorical plot. Categorical plot can be divided into three types: estimate plot, scatter plot, and distribution plot. So, categorical estimate plot can be divided into two types. Number one is bar plot and one is count plot. What is a bar plot? Let me show you. We have already studied in about bar plot in Matplotlib also. Here I am using day column, total bill, and data equals to tips. Same rule, you have to just write sns dot bar plot. Now you see Thursday total bill, Friday total bill, Saturday total bill, Sunday total bill. So maximum people come for Sunday. That is normal also. So to find the distribution of categorical data, you can use bar plot. Fine. Next one is count plot. See how it looks. If I run it, this one is count plot. Like Thursday, 60 people, Friday, 20, Saturday, more than 80, Sunday, 75. So this is a count plot. Okay, so you can see the count of observations in each category. Now next one is categorical distribution plot, box plot and volume plot. See, box plot also we studied in details that it is mainly used to show the quartiles. To know the 25% quartile, 50th quartile, 75th quartile, the median value, we plot a box plot. Let me show you. If I just run it, now see, x equal to day, that means these are the days, y equal to total bill. So you can see that Thursday, 25th quartile, 75th quartile, this is 50th quartile, this is the minimum value, this is the maximum value. So we can find the 5 values from a box plot. Minimum value, 25th quartile, 50th quartile or median value, third quartile or 75th quartile. Next is the maximum value. And what are all these things? Can you tell me? These are the outliers. Okay, if you have any doubt, you just go to the Matplotlib section. There I described box plot in details. like how it is divided into 100 percentiles, and what are the things we can derive from a box plot. Okay, here just understand that if I want to use box plot using Seaborn, we have to write sns.boxplot. You can plot box plot using matplotlib also. Okay, so this comes under categorical distribution plot. Next one is violin plot. Now to see how it looks. Just let me copy this one. If I paste and run it, see, you can see this is a KDE plot. We have just studied density function, and inside this you can see there is a box plot. So violin plot is a combination of KDE and box plot. Clear? Okay. Next one is categorical scatter plot. Now categorical scatter plot is also known as point plot or strip plot. It also displays the relationship between one categorical variable and one continuous variable. Now see, this is a strip plot. Strip plot, it looks like strip. So Thursday total bill, Friday, Saturday, Sunday. Saturday, Sunday fields are more, so you can see. So this is the way you can draw a strip plot. Okay. So we can say that if you want to plot a scatter plot on categorical data, then you have to use strip plot. If you want to plot scatter plot on numerical data, then you have to use sns.scatter plot. It's simple. Okay. Now one more type is swarm plot. Let me show you how it looks. If I just run it, then see it will look like swarm. So this is a strip plot and this is a swarm plot. So it just adds some noise, slightly noise, so that it does not overlap with each other and the visualization makes better. That is what is the difference between scatter plot and swarm plot. Okay. Okay. So we have completed categorical plot, bar plot, count plot, strip plot or categorical scatter plot, swarm plot adds a bit noise so that it does not overlap. Box plot gives us the quartiles. Violin plot, it adds the distribution plot, box plot, and with probability density functions. Okay. But suppose if I want to use the figure level function, then I have to just write sns.cat plot. Okay, let me show you this one. If I just copy this one and paste it, let me show you sns.cat plot. Here x equal to day, so these are the day. Y equal to total bill, kind equals to violin, violin plot I have drawn. Hue equal to sex, so that blue male, orange female, and data equal to tips. Okay, so I have used cat plot. This is the figure level plot. Here if you just change it to box, then what will happen? It will be a box plot. If you just change it to strip, see, if you just change it to swarm, clear? So a single line cat plot, here you have to just write kind equals to in which you want to get it. Okay. Box plot, violin plot, swarm plot, strip plot, and what are the other two? Bar plot, count plot. Let me show you this also. Bar, clear? Now let's understand one concept, that is faceting. Faceting means breaking down data into different categories. Suppose if I write here column equals to time. See what happens. Lunchtime, dinner time. Different graphs in a single figure. This is possible by figure level function. Cat plot is a figure level function. Here you can plot multiple graphs in a single figure. So this is a figure where you have plotted multiple axes. This is only possible by figure level function. Cat plot is a figure level function. Clear? Now if I write row equals to time, then it will be row wise. Let me show you. See. lunchtime, dinner time. Clear? So you can simply break down the data into different categories by using the concept known as Seaborn faceting. This is only possible in Seaborn, not in Matplotlib. And in Seaborn, you have to use figure level function to do this one. Okay. If I write bar plot and I delete kind equal to bar, and now if I run it, say unexpected keyword argument row. That means in access level function, you cannot use faceting. So as of now, we have completed relational plot, rel plot for figure level function, scatter plot, line plot, access level function. It finds the relationship between variables. Next, we have understood distribution, histogram, KDE, rag plot. Dist is the figure level function. All these are axis level function. Next, categorical. Cat plot is the figure level function, and all these things are axis level function. And if I want to use faceting, creating multiplots, then you have to use figure level function. Else, if you want, you can use axis level function. Clear? In our next class, we will study about all other things. Okay, till then, bye. Happy learning. Hello everyone, welcome back to this channel. Let's continue our C1 session. Okay, so as of now we have completed relational plot, distribution plot and categorical plot. Today we will start with matrix plot. This can be divided into two types, heat map and cluster map. Now you can say that the name suggests it will look like a matrix, like it must have rows and it must have columns. Okay, now let's first understand heat map. Let's read the definition. A heat map displays data in matrix format with colors representing values, and it is used to visualize the correlation between different variables. Okay, so highly positive correlations can be represented by one color, highly negative correlations can be represented by another color. What is correlation? The relationship. How, what is the impact of one variable if the other variable changes? That is what is correlation. Okay. Highly positive correlations means if one is increasing, then another one is also increasing. Highly negative correlations mean if one is increasing, another one is decreasing. Okay. So the effect of one variable on another variable is known as correlation. And to find the correlation, we can use heat map. Okay. Now first download a data set called flights data set. First, let's write import C1 as SNS. What is SNS? You can tell me. Now download the flights dataset sns dot load underscore dataset because this dataset is already in C1 library. All we have to do is just download the dataset flights. Now let me run this one and let's check what is there in flights. It's a small dataset, number of passengers in each month of any year. Okay, so first we have to convert it into a table which have rows and columns. Then only we can apply heat map. So first we will create a pivot table. Let's see how it looks. Flights underscore pivot equal to flights dot pivot, and we have to give index equals to month. So the index will be month. So the rows will be as per the month January, February, March, April, like this way. Columns will be year. So every year will be a column, individual columns, and values of the table will be taken from the passenger column. Okay, so we have created a small pivot table. Now let's see how it looks. Okay, for that we have to write flights underscore pivot. Let me run this. Clear? So January, February, March, April, all the months are indexed as we said. These are columns and values are passengers. These are known as pivot table. These are so much used while using with large data set. Now we will create a heat map on this. So all these numbers will be represented by colors. Let me show you. SNS dot heat map and under this flights pivot. Okay. Now if I run this, See, exactly copy of this one, but with colors. Clear? Now, if I want to see the numbers also, I have to write a not equals to true. Now, see what happens. Uh, this is overlapping. So simple, we have to use FMD equal to D. That means these numbers will be converted to integers. Now, it will be more visible. Clear? So, we can find the trend from here. Like you can see that in the month of August, July, June, September, in this month, there are more passengers taking flights. Okay, so you can understand the trend. You can also understand that in which month passengers are likely to take a flight. So you can increase the flight tickets accordingly that or decrease. Okay, or you can give any kind of offer. So in these months, maximum people are taking flights. Like in February, people are taking less flights in comparison because this portion is dark. In November, also, this portion is really dark, so people are not taking flights. So you can decrease the flight tickets to increase the sales. Okay, so these are the basic things we can derive from heat map. That is what is a heat map. Now, next one is cluster map. Let me show you. This one is cluster map. It performs hierarchical clustering to organize the data and it groups similar rows and columns together based on their values. Just let me copy this one and if I just paste it instead of heat map, I have to write cluster map. Now, let me show you. There will be a hierarchical clustering. The rows are clustered, the columns are clustered depending on their types. Here you can see that January, February, November, March. So the order has been changed. So simply we can say that it groups similar rows and columns together based on their values. Okay. So based on the values, it has grouped similar columns. Same looks like heat map, but it is performed on heat map and hierarchical clustering is formed. That is what is done by cluster map. Okay. So heat map and cluster map both comes under matrix plot because both of them look like matrix plot. Okay. Clear? Now let's understand the next one and this is multiplot. Multiplot, the name suggests that there will be more than one plot together. It can be divided into two plot. Number one is pair plot, number two is joint plot. Pair plot means you can understand that there will be pair-wise relationship of every numerical columns in the dataset. Let me first download TIFF's dataset. Then I will show you how pair plot works. SNS dot load underscore dataset site tips and I have to keep it in tips. Just check it once. Okay, clear this one. We know this dataset. Now I will create a pair plot on tips dataset. Now see what happens. Total will tip size. Three numerical columns. So there will be pair with all of these three numerical columns. So 3 into 3, 9. See here, total 9 plots. Total will tip, total tip, total will size. Tip, total will, tip, size, tip. Size, total will, size, tip, size. Okay, so total numerical columns 3 and every two columns will create a plot. That is what is done by pair plot. When you want to see all of the relationship in a single graph, then you can use pair plot. This is very much used. Okay. Because this is easy and you can visualize easily that what are the relationship. Okay. Now if you want, you can give any hue parameter also. If I just give hue equal to 6, now see what happens. Color will be there. For male, there will be different color. For female, there will be different color. Clear? Or if I give hue equals to time. Now see what happens. Okay. So lunch time, dinner time. This way also you can do. Clear? So this is what pair plot does. Now let's understand what is a joint plot. Joint plot means that will visualize the relationship between two variables along with their individual distributions. Let me show you this one. It is also very simple. A scatter plot between total wheel and tip. See total wheel and tip with their individual distribution. histogram. Histogram of total bill, histogram of tips. Okay, so in a single plot, histogram is also plotted and scatter is also plotted. That is why this is known as joint plot. Okay, clear? So we have completed matrix plot and multiplot. Heat map, cluster map, joint plot, pair plot. Now let's understand what is regression plot. Now to understand regression plot, let me tell you one thing, that there is a machine learning algorithm known as linear regression. There we will understand this concept in details. But as of now, I will just give you a simple brief so that you can understand what is the basic and how we can use Seaborn to do this kind of plot. Okay, let me tell you. Let's say we want to find the relationship between total bill and tips. We have some observed data, like this one is tips for this much of total bill, this one is tips for this much of total bill. Okay, so we have some observed data. Now our aim is that I know that for $30 total bill there is some amount of tips. For $40 total bill, some amount of tips. But my question is, what will be the tip? How much will be the tip for $35 bill? Now, to answer this, we need to find a relationship between tips and total bill. So, we want to draw a straight line by which we can get the answer. Like we will plot in this way, then we can find the tip if the total bill is $35. Okay. Now to find this straight line, we have to use linear regression algorithm. We will understand that in depth later. But for now, just understand that we have to find the straight line. This straight line can be this way, can be this way, can be this way also. So how will we find the best fit line? For that, we have to measure the errors. And what is the errors? Like see, if I predict that for $30 bill, this is the tip size. Okay. For $40 bill, this is the tip size. But the real tip may be different. So the real tip and the predicted tip. The real tip and the predicted tip. The difference between this are known as errors. And after we add all these errors, then we will measure that for which line the error is the lowest. And we will treat that line as the best fit line. Okay, so our job is to find the best fit line so that we can make a prediction based on total bill. Okay, so from the observed data, we will find the best fit line where the error will be less. Then we can predict how much will be the tip for a given amount of total bill. Clear? This plot is known as linear regression plot. That's what we can perform by C1. If you don't understand this as of now, just don't worry because this is a complete algorithm that we will learn while studying machine learning algorithms. But just know how we can plot this using C1 because that we are going to do later. So write SNS dot reg plot x equals to total bill y equal to tips. Data equal to tips. Just run it. Oh, y equal to tip. Sorry. Okay, so you can see this is what we are talking about. This is the best fit line. Here, if I want to know for $25 bill, like this one, what will be the tip size? So we just can simply connect this and we can find the tip size. Clear? So this is the best fit line. These are the observed values. And from this line, y equal to mx plus c, that is the formula of straight line. So we have to find m, we have to find the value of c. From where? From the observed data set. Okay, how to find? By calculating the errors. We will take only that straight line where the error is less. Okay, so this is simply regression plot. Okay, just have a basic idea. Don't go in depth for now. Okay, next understand linear regression plot. We can plot by LM plot also. Same, just let me show you. This is a figure level function. Now if I want, I can give hue equal to 6. Now let me run this one. Clear, blue, male, red, female. Now let's apply some faceting on this. Like column equals to time. Now see there will be time, lunch, dinner. So two graphs, lunch time, dinner time, clear. Or if you want, you can facet row wise, lunch, dinner, clear. Now the last one, that is residual plot. Residual plot means this will plot the residuals, the difference between the predicted value and the real value. Okay. Let me just copy this one and paste. I run it. Okay, so it plots the residuals between real data type and the predicted data types. So we have completed our Seaborn tutorial. We have completed relational, distribution, categorical, matrix plot, multiplot, and regression plot. Okay, so we have uh, almost done everything. Now, if you want to just decorate them, you can give X label, Y label, plot dot title, and we discussed about these things also. And we have already seen that Seaborn has many advanced feature which Matplotlib does not have, but for in many cases, we have to use matplotlib. Like you can see that we cannot plot pyplot using Seaborn. We need to be dependent on matplotlib. Or if we want to change the name, if we want to decorate, then also we have to be dependent on matplotlib function. Okay, so there are some advantages of using matplotlib and some advantages of using Seaborn. So congratulations, we have completed NumPy, Pandas, Matplotlib, and Seaborn. Okay, we will meet in our next video. Till then, bye. Happy learning.